Hello, welcome to Introduction to Java Programming. In this session, we will discuss about data types as part of the basic programming concepts of Java. In the previous session, we have discussed identifiers. As part of identifiers, we have seen what are variables, constants, keywords, and how to give names for classes, methods, interfaces, etc. Let's understand data types, which are also part of the identifiers. In Java, we have 8 primitive data types to represent numbers, characters, and Boolean values. When we speak of numbers, they can be whole numbers or they may be floating point numbers. The whole numbers are called integers and floating point numbers are called the decimal numbers. So we have 4 data types to represent integers and 2 data types to represent floating point numbers. In fact, we have a character data type, which is actually to represent the char set of Java, and the Boolean data type to have the logical values which are true and false. Let's understand these data types in detail. So these data types are called primitive types because Java defines 2 types of data. One is primitive, another is reference types. Reference types means class types. So any class you create, for example, a string class which is predefined is a reference type. You create a class called student, then student class is a reference type, and you can have variables created of that student class. So student S1, S2, S3. So this S1, S2, S3 are the reference variables of the class called a student. Let's now understand only the primitive types. In an object-oriented programming, every class is actually a data type. So we can have as many reference types of as possible, but Java defines 8 primitive types to represent the data. Primitive means the basic types. So you know Java has come from C and C++. So whatever the data types which are there in C and C++ have been carry forwarded to Java as well. As I told, there are 4 integer types. The first one is byte to represent numbers which are very small, and short numbers, short is the other data type to represent the numbers which are small to medium range, and integer to represent a little more bigger numbers, and we have long, which is actually to represent a very big numbers. Let's understand thoroughly. So byte, the size of the byte is 1 byte, so that's why it is called byte data type, and it has 8 bits. So with 8 bits, so total number we can actually represent is 2 to the power of 8 actually. So we can represent 2 to the power of 8 numbers. So I'm writing 2p8, that means 2 to the power of 8. So 2 power 8 is 256. Total 256 numbers can be represented using byte, and almost all data types are assigned data types in Java. So for any data type, there are 2 qualifiers. One is signed and another is size actually. So signed and unsigned we will have, and then we have size, short and long. But what Java says is, Java removes all that sign and size qualifiers. It just says there are 8 primitive data types, all are signed only except the character, and sign doesn't applicable for the Boolean value. So except this last 2, char and Boolean, all are signed only. That means they will have both negative numbers as well as the positive numbers. So now coming to the byte, which is also signed, so which have 2 power 8, so total 256 characters are there. 256 numbers you can represent, and which are actually from minus 128 to plus 127. So why one less than 128 means we will have 0 also. So we will include 0 also, right? So once we include 0, 0 is considered to be a positive number. So it's like this, minus 128 to 0, and then 1 to 127, total 256. Okay. So minus 128 is 2 power 7, and plus 127 is 2 power 7 minus 1 actually. So with 8 bits, how do we get minus 128? That is 2 power 7 means 1 bit is actually taken care by sign bit, and you are left with 7 bits. So 2 power 7 is actually 128. Okay, so out of 8 bits, 1 bit is a sign bit, right? So you are left with 7 bits only. So the range will be minus 2 power 7 to plus 2 power 7 minus 1. So if at all you want to represent any number where the maximum value is just 127, you can actually go for byte, so that only 1 byte of memory is occupied. So why do we have all these? Why do we have all these integer types? Why 4 types? So just to manage the memory efficiently. Okay, for example, I want a number 10. So I can actually declare that as a byte. So it will occupy only 1 byte. If I declare that as integer, it will occupy 4 bytes. If I declare that as a long, it occupies 8 bytes. Okay, just to manage the memory efficiently, these many data types are there for numbers actually. And same is the case with the floating point things also. Okay, yeah, then coming to the short is a little bigger than byte, which is also integer type, so to represent whole numbers, and it has 16 bits. So 16 bits means total 2 power 16 numbers are possible, and the range actually starts from minus 2 power so it will start from minus 2 to the power 15 to plus 2 to the power 15 minus 1, because 1 bit goes for a sign and you are left with only 15 bits. So 2 power 15 is 32,768, and it goes up to positive 32,767 because 0 has to be included. So total values which are possible is 2 power 16. 2 power 16. Okay, so yeah, that is 65,536 actually. So if at all we will say in numbers, and 2 power 16 is going to be 65,536. Let me actually write this one as well here. Yeah. So then coming to the most used data type, that is int. Okay, so int means integer. Of course, all are integers only, whole numbers. But int has a size of 32 bits, that means 4 bytes. So you can actually represent total 2 power 32 numbers. So you can actually have total 2 power 32 numbers represented. So because it is signed, so we will be having minus 2 power 31 to plus 2 power 31 minus 1. So what are the values actually? So if you speak values in numbers, it will actually start from minus 2.1 billion to plus 2.1 billions. Okay, so 1 billion is 100 crores actually. 1 billion is 100 crores. So 2.1 billion means 200 crores minus 200 crores to plus 200 crores. If your value is that much big, then you can actually go for integer. Okay, so more often if you take any factorial number which is actually some 15 or 16, then you will actually go beyond this particular integer also. Okay, so then you have to go for a bigger data type, that is long. So long actually has the highest size, that is 64 bits. So total 2 power 64 numbers are possible. So which is very big number. So 2 to the power of 64, it's a very big number, and it occupies 8 bytes of the space. So the range actually starts from minus 4,000 trillion to plus 4,000 trillion. 1 trillion is 1 lakh crores. 1 trillion is 1 lakh crores. So that much big number you can actually represent with long. Okay, just to have numbers in your range and to save the memory, we have these 4 types of integers. Okay, and few points one has to learn here is default value and default type. Default value and default type, because we have so many integer types, we should know about default types. And what is the default value? For example, if I say just int x, what is the value of this x? Okay, so the default value for all integers is actually 0. The default value is 0. Okay, byte is also 0, short also 0, int also 0. But when you speak of long, we have to say 0l actually. When we say 0l in smaller case or capital case. Okay, otherwise that will be treated as integer. If you are not saying L, the long value also treated as integer. The reason is the default type for all integers is int. So the default type for all these integers is actually int. So that means, yeah, so you need to understand in this way. So that means, for example, if I say 10, what is 10? Is it a byte? Yes, it is in the range of byte. It is a short. Yes, it is in the range of short. It is in the range of int. It is also in the range of long. So what is it? Okay, that's why Java defines the default type. The default type of integers is int. So when I say 10, it is going to be integer. So in order to make you understand this, let me actually go and write a small program. So here I'm actually declaring a byte variable. Let's say byte b equal to 100. So this 100 is going to be a byte value because I am saying it's a specifically byte value. Now here I just want to do something like this. So this b equal to, I just want to add 100 to this. B equal to b plus 100. And just I want to print this particular b value. Okay, so what is the value? What is the output of this? It is 200, which is not in the byte range. So I just want to just keep 25 only here. Byte b equal to 100 and b equal to b plus 25. B is 100 and plus 25, 125, which is well within the range of a byte. The byte had range up to 127 plus 127, right? So usually everybody will expect an output of 125. Okay, but if you know what is default type, then you can actually answer this very well. So let me actually compile and show you that this particular thing actually, yeah, so let me actually see this first is there here. Yeah, first.java is there over here. So let me compile here Java C first.java. Now you can actually see the outcome. If you see this, it says incompatible types. When I am writing b equal to b plus 25, it says incompatible type. Possible lossy conversion from int to byte. So what's actually happening? Just now I told here, right? So 25, when you write like this, it's an integer, right? The default type is integer. So 25 is a whole number, it is an integer. So always the expression evaluates to highest data type. So byte plus int is always going to give me integer only. Fine. So 100 plus 25, 125, but this 125 is an integer. So that integer you cannot put into a byte. Integer actually takes 4 bytes. Byte is only 1 byte, right? So 4 bytes you cannot put into 1 byte. So this is the error actually. That's why it is saying possible lossy conversion from into byte. Okay, that's the importance of actually the default type. Okay, so now how to make this work? How to make this work? So what we have to do is we have to explicitly typecast. So how to typecast? So in Java, in order to typecast, you have to keep the data type in parentheses, and whole of this expression you also have to keep actually, because the whole of this expression is integer 125 that I want to convert to byte, and byte is well within the range. Okay, so now you can expect the output equal to 125. Let's see whether it get compiles or not. So Java C first.java compiled successfully, and then I'm saying Java first, and it's actually 125. Okay, so that's the importance of a default type. And in fact, the default values also are important to understand, because whenever an object is created, the constructor constructs the instance members with their default values initially. So that one has to understand. So that's about integers, and then we move to floating point numbers. So we have two data types to represent the numbers with the decimal points. So we have float, which is of 4 bytes, and we have double, which is actually of 8 bytes. So float actually will have a precision. Float actually have a precision up to 6 positions only. That means after dot, after decimal point, you will have 6 precisions only. Okay, the accuracy is up to 6 precisions. So for example, 3.141592 something. After dot, you will have six places only. Whereas the double has more accuracy. So the double in the sense it's actually double precision. The double data type in the sense double precision. The double data type has double precision. So after dot in Java, you have 15 places. You will have maximum 15 places, decimal places actually. So double precision. So float is actually a single precision. It's a single precision, and double is actually a double precision. So now it has 6 decimal places and it has 15 decimal places. Okay, so that's the difference actually. Single precision is float, double precision is double data type, and their sizes also matter actually. Float size uh, is 4 bytes, and the range is actually so 3.40 into 10 to the power of 38. Okay, 2, this is 2, and 1.40 into 10 to the power of minus 45. So both designed actually, so negative values as well as positive values actually. So its range actually starts from 1.40 into 10 power minus 45 to 3.40 into 10 power 38 actually. In the same fashion, double has very big range, which is actually starts from 4.9 into 10 to the power of minus 324 to 1.79 into 10 to the power of 308. So this is the range actually. So of course we can calculate the range with uh, the powers as well actually, minus 2 power 63 to plus 2 power 63. So that is somewhere equivalent to this particular value only. Yeah. So yeah, in order to represent numbers, we have 6 data types, right? 4 integers and 2 floating point types. So here in the floating also, we need to speak of this default value and the default type. Okay, because you have more than one data type here, so you need to speak of what is the default value and what is the default type. So the default value for float is actually 0.0 f. We need to say f. Otherwise it will become double value. And default value for the double is actually going to be 0.0. Otherwise you can also mention d. Even if you don't say d also, no problem, it is double value only. So that means what? That means what? Default type here is actually double. So that's why mostly in Java we use integers because that is a default type. We use double value, we use double type, and we use Boolean. Character also most of the time you will not use because character can be done with the help of a string class. String is a sequence of character. There we can actually make use of a character. Okay, so that means here when the default type is double, when you say 3.14, 3.14 is going to be a double value. You want to make as a float, you have to make this as a f. Otherwise, it's going to be a double value. Okay, so in order to make you understand this default type, let me actually go to my program and let me show you this thing as well. So whenever I say float some f equal to so 3.14159. Okay, so this line is going to give me a compile time error. This line is going to give me a compile time error. The reason is float f equal to 3.149. Whenever you say 3.1415 something, it's going to be a double value. It's not a float value. For float value, you have to clearly say f actually. So let me actually show you by compiling this Java C first.java, and here you can see incompatible types, possible lossy conversion from double to float. Okay, so whenever you declare a float value, you must have to give capital F or small f. Okay, now it will get compiled perfectly. It got compiled, right? So now the next statement also, let me actually write f equal to f plus, okay, f plus 3.14. I just want to add some 3.14. So here this statement is again a compile time error. Okay, this statement is again a compile time error. This is set actually. This is again a compile time error because 3.14 is a double value. Okay, so you want to see Just compile this and you see that there is a compile time error. Okay, so how to make this correct? Need not to typecast, you just need to make F, and this compile time error will go off, and then you can actually print this particular F, and you will get the value. You will get the value. So now let me compile this. So compiled successfully, and I can actually run. So you can actually see 6.2815905 actually. Okay. Yeah. So yeah, one correction actually. So if you see the output, it's actually having 7, right? So after dot 7 decimal points. So it's not 6 actually, it's 7 decimal points. Let me correct this. It's a 7 decimal points and it is actually 15 decimal points. So float has 7 decimal points and double has 15 decimal points, and the default type is actually double. So let's now move to character. So character we have already understood as part of the char set. So character size is 2 bytes, it is 16-bit and it's a Unicode char set. And here the range is 0 to 65,536. So character is actually unsigned. Okay, character is unsigned, it's not signed. It's not having negative values. It starts with 0 and goes up to 65,536. And we know what is 0, what is 65, what is 97, what is 122. 65 is capital A, 48 is 0, 120 is small z, and 0 to 32 are non-printable characters, and there are 32 printable characters. This is all we have understood. So nothing much actually we can discuss about the character. And see, this is a single data type, right? So it's only one, so you don't have a default data type. Okay, but default value is important. So what is the default value for a character? The default value of a character is /u 4 zeros, /u 4 zeros, because it's a Unicode, right? So /u means Unicode followed by that hexadecimal number. 0000 is nothing but 0 only. So 0 we have a null character. It's a non-printable character. Okay, so like that you will have the next character is something like this /u 0001. Okay, so and every character is represented in single quote like this. But what is the default value? Default value is this, and like that you can have values. So sometimes don't confuse actually. So somebody says, is it a character or not? So you can actually say A, B, C, D. It's a character because it's hexadecimal value, right? So 0 to 9 numbers and then A to F hexadecimal numbers. So A, B, C, D is a proper character. In the same fashion, somebody can actually ask you /u, and they are telling some E of 1 to AB. So is it a character? No, only 4 things should be there. EF12, this is a character, or EFAB, it's a character, right? So any character which is hexadecimal with 4 characters, right? So then it's a valid character actually. So that's about the character. And then coming to the Boolean type actually. So Boolean type represents logical values. So we have 2 values, true and false. So you should write them like this only, no single quotes, no double quotes. And somebody asks what is the size of a Boolean. Java doesn't give any size. Java says it's a machine dependent. It's a machine dependent. Okay. So sign and size will not applicable this. Okay. So we don't have signed or unsigned for this, and you don't have any size for this also. What is the default value? Default type doesn't applicable because it's only one, right? It's only one type Boolean. So the default value is actually false. The default value is false. Okay. So for all the 8 primitive types, we understand their sizes, ranges, default values, and default types wherever it is necessary. Okay. So this is about the primitive data types in Java. So hope you have understood. So I will see you again with a new session. So that's actually on operators. Thank you.